Morning, guys. Sorry that I could not be there to go ahead and help you guys out with this, but I did the next best thing. I went ahead and taped myself. I have to first of all apologize for a couple things. Last night we played a football game against Palatine. My voice is a little bit hoarse, and I know the videotape it will probably not be the same quality as if I was in person. But I'm going to give it the best try I can and help you guys out a little bit with your homework. So yesterday, basically what we had done was we took the problem that we had done in class with one string and one block, and we solved for the tension. Today, we're going to up it a little bit. We're going to go ahead and we're going to do a little bit more with it. So for today, and you should be copying this down as we're going. That means you, Cody. All right, good. Carson, you too. All right, Howard, definitely get it going. All right, we're going to go ahead and we're going to draw the wall just as we did before. But now today we're going to have two blocks here. And again, you should be copying this down. And both of the blocks are going to have 10 kilogram mass. And like I said, today we're going to be going ahead and calculating two tensions, T1 and T2. Now the process by which we do this, again, as a solid process, can be applied to any problem. So when memorizing certain things, you memorize the process, not the actual problems themselves, because every problem will be a little bit different. So we're going to go ahead by starting by drawing a free body diagram. Everybody should do it. Don't cost nothing. Yeah, okay, copy that down. All right, here we go. We got the tension one that's up. We're going to have two forces that are down. Here's the confusing thing about that. We're going to have the weight. In addition, we're going to have this tension right here. If you're looking at the box, there are two strings touching it. There's a string on top and a string on the bottom. So two strings touching it. So there's also going to be a T2 that's down right there. So that's our first free body diagram. Romeo, copy that down. Megan, check on it, make sure. Good. Okay, next box right here. We got our weight for that object. And I don't need to decipher between the weights because they're going to be the same weights here. And then I'm also going to have a tension 2 that's up. So once again, we've done our free body diagram. That's the first step. Next step now, when you're doing this next step right here, remember, just because I'm not there doesn't mean you don't say it. All right, here we go. We're going to go sum of the forces equals. Very nice. Let's go ahead and set that equal to your mama. All right, we got the next question. God's acceleration? I said God's acceleration? Very good. All right, in this one we have hell no. All right, there is no acceleration in this particular one because the objects aren't moving. All right, we're going to do the same thing down here. Sum of the forces equals yo mama. God's acceleration? Hell no. And in this particular one, this is where I want to start. With this one, I have two forces right here. I have one force that's up. That one's going to be positive. I have one force that's down. That one's going to be negative. We're going to set that equal to 0. Remember, this is the placeholder, all right? This won't always be 0, all right? There'll be times when there's a number here, so we're going to, again, continue to go ahead and have that in there, all right, for now. So let's go ahead and solve for T2. I'm going to push the W out over to the other side. This is something we should have known at the start, that those two forces were equal, because if that wasn't true, the object would accelerate up or accelerate down. So those two things are equal. This looks a lot like yesterday. It looks a lot like yesterday in that this is the same expression. I think we all know that weight from yesterday's equation is mass times gravity. This is not the weight. All right, mass is in kilograms, weight is in newtons. So it's almost like we're converting. So what we have here is the mass, which is 10 kilograms, multiplied by gravity, which is 9.8. And just recall from yesterday that this number here for gravity is positive. When we plug that in, it's got to be positive from now on. We will account for the negative nature of gravity in a different way. And there's where we did it. Okay, this line is down, that line is minus, and we've already accounted for that. So whenever you plug in gravity, it's going to be positive 9.8. At this point, who can't do this? This is going to be 98 newtons, just as we had done yesterday, which makes sense. It's really not a different problem if we cover up what's up on top. Now let's jump to this one up here. It's going to be a little harder, but we're going to apply the same process as before. We're going to look at the sum of the forces. There are three forces here. One of them is positive, since that one is up. We've got 2 here that are down, so those 2 are going to be negative. And once again, that's all going to equal 0. The 0 is a placeholder, all right? It won't always be 0. As you start to do problems that are harder, there will be a term right there, and again, that'll make the problems a little bit harder. In this particular problem, we're solving for T1, all right? So we've got T1 here equals T2 plus W. Now, luckily for us, we solve for T2. That's going to be 98. All I'm doing is taking it from right here. It's a substitution step. And then the next part of this, the weight, I've already done the weight calculation. I know that weight is mass times gravity, so that's going to be plus another 98 newtons. So if I take a look at this, all right, I'm going to have a total of 196 newtons. In retrospect now, this should make a lot of sense. Take a look down here. 98 newtons is the tension here because it's holding how many blocks? 1 block. Good. All right. Up here, how many is this holding up? All right. This tension is holding up 1 block, 2 blocks. So it's holding 2 blocks. So therefore, the tension should be, I don't hear you, Cat. Nice job. Twice as much. Twice as much. All right. So that's the first problem. In our next problem, it's going to get even a little bit harder.